Hello everyone, here we have inference about two means, independent samples. On this part again, we're going to work on null and alternative hypothesis. So here we have null and this one alternative. These two are based on the example we have here on this part. So what we have mu1 representing mean time until cold symptoms go away for individuals taking the drug. Mu2 as mean time until cold symptoms go away for individuals taking placebo. So as always for null, we have these two are equal to. And here, okay, we have less than. So if the drug is effective, the mean time until the cold symptoms go away should be less for individuals taking the drug. So this mu1 should be less than mu2. That's why we have less than, because here we have less than. Okay, so as always before starting, we should have all these three requirements. Again, the first one, we should have simple random sample. Then second part, since we have two populations on this part, we have two samples. So the first sample size should be greater than or equal to 30, and also second sample size should be greater than or equal to 30. Remember, for when we had mean, we used this part instead of n times p times q greater than or equal to 10. That was for population proportion. For mean, we using this part. So we should have greater than or equal to 30, or our population should be normally distributed. So normally distributed. And the third one was that our sample values are independent. And after these requirements, starting all these 6 steps again. So the first part, finding where the null and alternative is, again for null, for all of these we have equal to on top. And when we have to tell for alternative we have is not equal to. When it's left, it's less than. When it's right, it's greater than. And mu1 here is the population mean for the first population. So it's population mean. And here mu2 again is population mean, and that is for second population. Okay, then step 2, we should find alpha level of significance depending on the seriousness of making a type 1 error. Step 3, finding test, finding t or compute the test statistic. So t is equal to the difference between sample mean divided by square root of sample standard deviation squared divided by sample size. Do the same thing for second population and adding these. I remember we had this one for when we had one population. When was one population or one mean in this case, since I'm using mean, let's write mean. So when we had one mean, here in this case we have two means. T was equal to sample mean minus mean divided by sample standard deviation divided by square root of n. So this was for one mean. But here is, we have, based on what we have here on top, we have two means. So this is for two means. So this one is approximately like, okay, student t distribution. We can say, yeah, the same as that one. So to find that part, we can use table or calculator. It's better to use calculator. to approximate the p-value. So how much the p-value is using calculator, and use the smaller of. So using smaller of either this one or this one degree of freedom. So if, for example, you had N1 was equal to 37 and N2 was equal to 45, so degree of freedom for this one we have 36. So 37 minus 1 is 36, and here degree of freedom is equal to 44. We should choose the smaller one, so choosing this one, smaller. So choosing smaller of these for degree of freedom. Then step 4, finding, okay, p-value. Again, we have to tell left tail, right tail. We want to see which one is. So when we have to tell p-value as sum of the area in the tails, this one plus this one. When we have left tail is area to the left, when is right tail is area to the right. Then step 5, we want to see if we should reject null hypothesis or not. So if p was less than alpha, then reject null. Then step 6, state conclusion. Okay, I want to add something here for the sport T. We can, okay, here we can call this T. Okay, we're calling that Welch T. So that's Welch T. And also in general, T is equal to differences of sample means minus this part and then divided by what we had in denominator. Okay, well, I don't have this one here on top because this part, since for null we have mu1 equal to mu2, using this part, mu1 minus mu2 is equal to 0. So using that part, since we have that for null, this is 0. So since this was 0, I didn't write that part here. Researchers conducted a randomized double-blind study to measure the effects of drug. What we have here, a total of 115 patients, and they were randomly divided into 2 groups. Group 1, sample size is 55, and second group, sample size is 60. And the effectiveness of drug was measured. The results are presented in this table. So what we have, the sample size for experimental group, the first group, so this is group 1. This was group 2. So for experimental group, sample size is 55, mean improvement 14.8, and sample standard deviation 12.5. And here for our second group, we have N at 60, mean improvement is 8.1, and sample standard deviation 12.7. Okay, part A. Is this an observational study or a design experiment? We have this part in the first chapter. Since we have treatment, this is design experiment. So this is designed. Since a treatment was given. Okay, then part B, what must be true regarding the populations to use which t-test to compare the means. So that means we should have all those three requirements. So the first one was that we should have simple random sample. Our sample values are independent. So independence. And the third one, our sample size should be greater than or equal to 30. So this is for both of these samples. Okay, so we should have this one or normally distributed. Okay, now part C, does the evidence suggest that the experimental group experienced a larger mean improvement than the control group, and alpha is 1%. So starting with step 1, what is null and alternative. So for alternative, okay, experimental group experienced a larger mean than control group. So this was group 1, and here control group was group number 2. So what we have is mean for the first one larger than, so it's greater than mean for second group. Okay, then step 2, alpha is given as 1%. Then step 3, t-test. Okay, so what we have for sample mean for the first group is 14.8, and for second group is 8.1. Standard deviation 12.5 for the first one, 12.7 for second group. And sample size is 55. And here sample size 60. Okay, rounding it, the answer is 2.849. Okay, let me go back here. So here in this step, we said that, okay, to find a p-value, you should use a smaller degree of freedom. What that means, here we should use degree of freedom as 54. Okay, so based on this part, to find p-value, degree of freedom is 55 minus 1 is 54. Use a smaller sample size. To find degree of freedom. Okay, I'm not using this on this board. Okay, the next step 4. Now I want to find p-value. I want to use calculator to find p. So first step, press stat, then test, then scroll down, choosing number 4 is 2 sample t-test. Then we have test, then enter, then okay, scroll down and choosing number 4 and then enter. Okay, then after pressing number 4, we have these. So you should have the sport stat, not choosing data because I'm not entering data. So choosing stats, then enter all these data. Sample mean for the first group was 14.8, standard deviation 12.5, sample size is 55, and do same thing for the second group. Second group, sample mean 8.1, standard deviation 12.7, and sample size 60. And on this part, our alternative was mu1 greater than mu2, so choosing this right tail, so it's greater than mu2. And for the pooling, no pooling, so choosing no. Okay, then scroll down. We have this part is calculate, so enter. Okay, so here we have result. Our t is exactly the same as what we got here is 2.849. We rounded that. And then p-value is 0.0026 on around those 4 decimal places. And degree of freedom, here I said that we should use smaller sample size. So using 54, that is when we're trying to use table, but when using technology, you want to have different degree of freedom. So you have 112.4181. So if we run it, it's 42. So 112, which is larger than what we got here, is 54. So it's better to use calculator. And so writing that part here on this board, we have 0.0026. Okay, so P is 0.0026. Okay, then step 5, comparing P and alpha. Is P less than alpha? P is 0.0026, less than 1%. Okay, the answer is yes. What that means, reject null hypothesis. Okay, and on that part here, that this one is right tail. So it's right tail. Test. Now step 6. State conclusion based on what we got here in step 5. Since we are rejecting null hypothesis, what that means, there is sufficient evidence to conclude the improvement in the treatment um, group was greater than control group. Okay, to conclude that, the improvement in the treatment group was greater than the control group. Okay, now what we have here is that degrees of freedom in by hand solution will not equal degrees of freedom in technology. Exactly what I explained here on top, that the degree of freedom using calculator was 112 something. But if, okay, so that was using technology. Unless you use the degree of freedom using this formula to compute that one using the first and second sample size. But this is harder, so you need more time to find degree of freedom and then using that to find the answer for that part. So that's why it's better to use calculator. It's faster to find it. Okay, we finished this example. Now next part, construct and interpret confidence interval regarding the difference of two independent means. So this part is exactly the same as population proportion. When we had two population proportions, and the only difference here, instead of using sample proportion, we're gonna use sample mean. So the difference between these two samples means, and then minus plus margin of error, and this is what we have for margin of error is equal to t times square root of standard deviation square divided by sample size. This is for first group and this is for the second group or second population. And how we can find this t using smaller of n1, so either this one or this one, depending on which one is smaller, to find degree of freedom. So again, use smaller degree of freedom. Okay, example. Okay, researcher monitor the progress the students made toward completing a bachelor's degree. Okay. He will not determine whether students who first in community college took longer to attain a bachelor's degree than those who immediately attended and remained at the 4-year institution. Okay. Here we have these data. So the first group we have community college. Okay, and then transferring to 4-year university. And this column, the second group is no transfer. Part A does even suggest that community college transfer students take longer to attain a bachelor's degree using alpha is 1%. So we need to test. So hypothesis testing, step 1. Okay, null and alternative. So So here on the sport group, the first group and second group, for the first group, we have community college. So I'm using CC for community college, and that is equal to here is no transfer. So I'm using NT. Okay, and then for, let's see what we had for alternative. Okay, there's the sport. Okay, he wanna determine whether students who first attended community college, so that is community college to longer, okay, taking longer, comparing that with no transfer. Okay, so that was step one. Then step two, alpha is again 1%. Then step three, finding t. Okay, so that is equal to for sample mean. So this is x bar 1 for sample mean, and this is sample standard deviation. Okay, 5.43 minus 4.43 divided by, we have 1.162 squared and as 268. This part, we have 1.015 squared divided by n is 1145. Okay, running it is 12.977. Okay, here again I want to mention that we should use a smaller sample size to find degree of freedom. So degree of freedom is here 268 minus 1 is 267. Okay, now step 4. And this part we have, since this one was greater than, we have right shell. So finding p-value. Again, using TI 8483 for stat, then test, then scroll down, choosing number 4. For stat, then test, then scroll down, choosing number 4. It's 2 sample tests. Enter. So on this board we have, okay, let me take another one. Okay, here we have stats, and then enter all the data we have for this board. For the first group, sample mean is 5.43, standard deviation 1.162, and sample size was 268. Enter all these for second group. Then here again we have right tail, so choosing this one is greater than mu2, and then again no pooling, and then scroll down. Okay, so choosing this one, then enter. Okay, so I'm choosing this to calculate. After enter, we have these T as 12.977. See, we got exactly the same thing. And then P value is 2. Okay, 84, 28, 85. I want to round it to 2.84. And this is what this means is multiplied by 10 to the power negative 32. Okay, I want to write exactly what I have here, but rounding it to those two decimal places. I'm not using that one to write the decimal points because I don't want to write all those zeros. And what is important here, again, see, degree of freedom is 368, but using the smaller sample size, degree of freedom was 267. Okay, that was here. Okay, 267, which is different from what we got here using calculator. Okay, so p-value is 2.84 times 10 to the power negative 32. Okay, I rounded that to 2.84. Okay, then step 5. Is p less than alpha. This one is obviously less than 1%. So it's 2.84 multiplied by 10 to the power negative 32, less than 1%, yes. So reject, no. Okay, then step 6, state conclusion. So based on what we got here in step 5, there is sufficient evidence to conclude that the mean time to graduate is higher for students that start in a community college. I'm using CC. Then those who started a 4-year university. 4-year university. Okay, we finished that part. Now, part B, constructing 95% confidence interval for mu. So this part is for community college, minus mu, no transfer. to approximate the mean additional time it takes to complete bachelor's degree if you begin in community college. Okay, so confidence interval. We need to find the sport. And what we had at alpha based on what we have here, confidence. So 95% confidence interval for these two groups. Alpha is 1 minus 95%. So alpha is 5%. And then based on this, alpha finding T. So alpha divided by 2. Then degree of freedom was 267. Based on what I said, okay, we need to choose the smaller sample size to find degree of freedom. So finding the sport using calculator inverse T. We had the sport before. So as I said, this one is what we have on right. So this is right area. When you're entering data into calculator using what you have in left, so 1 minus 0.025 is 0.975, and here degree of freedom 267. Okay, the answer is 1.969. Okay, now finding margin of error. So T times square root of okay, that is equal to 1.969 times our sample size is 1.162, and here we have 1.015. Sample size 268, 1145. Okay, so running it, the answer is 0.1517. Okay, now finding based on what we got here, now finding confidence interval. So confidence interval, we have upper bound, lower bound. For upper bound, we have plus E, and for lower bound, minus E. So finding the difference between these two sample mean. Then add E as 0.1517 Writing same thing here for lower one. The only difference, now we're subtracting margin of error. Okay, so for upper bound we have 1.152 and for lower bound is 0.848. So based on that, confidence interval is 0.848, 1.152. So this is our final answer. So based on that, what this confidence interval means, it can be 95%. So interpreting that as we can be 95% confident that the mean additional time to graduate for community college so I'm using CC again. For community college student, it's between these two numbers. Between 0.848 years and 1.152 years. Okay, now part C, do the result of parts A and B imply that community college causes you to take extra time to earn bachelor's degree? Okay, so the answer for this part is no, because observational data cannot prove causation. Remember, we had all these observational and causation, all these definitions on in chapter 1. So the answer for this part is no, as based on observational data, we cannot prove causation only. In association. You don't need to write this part. So the answer is just, okay, no, observational data cannot prove causation. Okay, and then cite some reasons that you think might contribute to the extra time to graduate. Okay, let's have one example here. So community college students may be, okay, working more. So this can be a reason. Which doesn't allow them to take additional classes. Okay, we finished this example, and okay, and we finished the sport.